Learning Objective 4 from Section 4.3 says, interpret output from a statistical program and/or calculator to carry out inference for the difference of two means. We'll use GeoGebra output. Here's the first example. The General Social Survey collected data on the hours worked per week for U.S. residents from two education groups, those with and those without a college degree. A confidence interval for mu with degree minus mu without degree was computed in GeoGebra, and the results are given below. Assume the conditions are met. Fill in the blanks to correctly interpret the confidence interval. You can see that we selected a t-estimate for the difference of means. A confidence level of 0.9 was entered. And then we have the data for the first sample, that's our with degree group, and the second sample, which is our without degree group. And then we have the output, which includes the lower limit and the upper limit of our confidence interval. To interpret a confidence interval, we'll need those lower and upper limits, and we will also need the confidence level. 0.9 means we have 90% confidence. We're going to fill in these blanks, and notice the instructions here at the end say to fill in the first three blanks with the appropriate values, and then fill in the last two blanks with either those in the sample or all U.S. residents. Okay, the confidence level was 0.9, so we're going to say that we are 90% confident that the interval that starts at 0.9337 and extends up to 3.8663 captures the difference between the mean hours worked per week for all U.S. residents. The reason we're saying all U.S. residents is because anytime we do inference, it is about the population parameter. So it's the difference between means for all U.S. residents, not just those in the sample, because that would be a sample statistic. So let's read this entire interpretation. We are 90% confident that the interval from 0.9337 to 3.8663 captures the difference between the mean hours worked per week for all U.S. residents with a college degree and all U.S. residents without a college degree. Here's the second example. Is there a difference between the average age of Best Actress Oscar winners and Best Actor Oscar winners? The ages of 32 randomly selected Best Actress winners and 32 randomly selected Best Actor winners were recorded. Assume the conditions are met to test the hypotheses. H naught, mu sub actress minus mu sub actor equals 0, versus the alternative hypothesis, the mean for actresses minus the mean for actors is not equal to 0. We're going to use a significance level of alpha equals 0.05. Here's the GeoGebra output. We did a t-test for the difference of means. The claimed value is 0, and we highlighted the not equal to symbol as indicated in our alternative hypothesis. Here are the data values for actresses, and here are the data values for actors, and here's our output. So what is the test statistic? The test statistic is given in the output as t. So it is t equals negative 3.5788. And the p-value is given right below it, 0.0007. Recall that the significance level we were told to use was alpha equals 0.05. Since 0.0007 is less than 0.05, we will reject the null hypothesis. And we can answer our last question here, which is, do the data support the claim that there is a difference between the average age of Best Actress Oscar winners and Best Actor Oscar winners? Well, yes, since the p-value is less than 0.05, there is sufficient evidence to conclude that there is a difference between the average age of Best Actress and Best Actor Oscar winners.